I'm with Professor Sethu. I met Professor Sethu in Edinburgh and then on my flight to Dubai, and that's where we had a cool discussion. Professor Sethu, you are authority in robotics, you are a practitioner and a teacher. Please introduce yourself, tell us something about what you do and what you have done and what you want to do, and then we'll carry our conversation in context of robotics in India.
So first of all, welcome to you, Ravi, the Cochin. So I'm very, very honored to have you in my home. So it's one of my passions to come back and spend some time in India. So I think this is a great place to spend some time. So welcome here. So my name is Sethu Vijayakumar. I'm Professor of Robotics at Edinburgh University. And I'm also the co-director of the Alan Turing Institute's AI program. So the Alan Turing Institute is the National Centre for UK's data science and artificial intelligence. So in a way, I have sort of two caps on. On the one hand, I direct the Edinburgh Centre for Robotics, which is an initiative which puts together world-leading equipment, world-leading training for people, for students, as well as working with local councils to implement or deploy robots. On the other hat, I have this sort of 50% of my time is with the Alan Turing Institute, which is effectively creating a roadmap for UK's next 20 years of how AI and robotics is going to go forward. So we inform the government, we inform number 10 about what are the right strategies, what are the right areas to focus on in terms of which areas which needs more resource, how do we make sure that there is no dearth of the pipeline of the knowledge coming through. So at the moment, we've got huge demand for AI practitioners and roboticists. What we're seeing is that in the next 5 to 10 years, we will have a huge shortfall. So how do we fix that so that we don't have a huge problem later on? So that's my sort of two roles. But really at heart, I am a roboticist, and that's what you said. So my passion is on doing the itty-gritty, the getting your hands dirty with the programming, with the software engineering, the programs that we handle with one of the flagship projects is with NASA. And that is the Johnson Space Centre's effort in putting a humanoid robot to Mars. And one of the things we do as part of our group is play a small part in that big puzzle in terms of creating software algorithms for balancing, for full body motion control and motion planning in very complex environments. So that's a short summary of what I do.
Cool. So let's start with humanoids and robotics and put them in context of India. My interest or my body of work is totally at a time and space today, totally devoted to solving problems which are related to India.
Yeah.
Few things which I wanted to pick your brain and take your advice and help people who are going to hear this for two aspects. One, why they should invest in robotics, and secondly, what are the use cases and how robotics solve problems. But fundamentally, whenever you talk about robotics in a context of emerging economy like India, two questions come. One, politics of robotics, which is employment. Take up employment. Sure. Second thing, I don't have that kind of money. Whereas robotics, more the study of or science and engineering of robotics is way more than just humanoids and give them citizenships. So let's talk about non-sexy part of robotics and educate us engineering. How does it solve problems in the context of emerging economies?
So I think very good 2 points. So let's take that one at a time. So the first thing you mentioned was about jobs. And so I get asked that all the time because I'm sitting there trying to push robotics. It's much more, as you rightly pointed out, it's much more easy to sell it in a Western context because you've got significant problems with the inverted pyramid in the West. So my view is slightly broader and I'm more optimistic about robotics because in many cases, we are enabling things that is not possible today with, even if you have an infinite manpower, there are certain things that humans can't do. So I'll give you some examples. So when you use your mobile phone to navigate and come here with your GPS, the way it works is you need a huge amount of rare earth materials to enable that cell phone technology, whether be it satellites, whether be it what's on the phone. And rare earth materials are becoming hugely rare. There's a big international global fight now in the context of who owns the largest supply of rare earth materials. So one of the things robotics is going to help is in finding new sources of rare earth materials. In the Indian context, that kind of doesn't hold much water. But I keep telling people that robotics is much broader than that. So robotics can, for example, enable us to discover new sources of rare earth materials. It could be mining underneath our oceans, could be going to another planet on a meteor and mining it and bringing it back to Earth. So these are examples of doing things that are not physically feasible without the help of robotics. So it's not about taking jobs, but creating new opportunities. On a similar vein, in lots of cases, we are building these smart cities of the future. In India, in big metros like Delhi, Bangalore, Madras, in Mumbai, we've got a huge network of underground metro systems, high-rise buildings, and eventually each of these systems will need a certain level of repair, management, inspection. These things, they are not physically feasible. Even if you employ all the manpower in India to run it in a safe way, it is not possible. So we need robots to do that. So that's the kind of practicality side of things. And there is, of course, the other bit is the more efficiency side of things. So robots can do things much more efficiently with less number of mistakes. So indeed, it will replace certain human jobs, which I think are more mundane and sort of boring kind of jobs. So we can potentially move resources towards more creative jobs. So I think that is my vision on robotics is that. And the second question you asked was more about so I think in terms of the politics of the robotics, that was more the kind of job side of things, which we looked at. But in some sense, the other side of the story is that when we talk about robotics, there are certain things that we can improve massively. So in the context of service industry, we have seen many cases where human inefficiency brings down the overall service quality. It also improves net cost. It may be cheaper in the short term, but in the long term, the net cost of trying to fix something that goes wrong is much higher. So in the context of smart machines, smart buildings, we have to address that. And I think this is a good way of using technology to address it.
So let's go a little bit deeper into politics of robotics, or rather politics of technology, robotics and AI when you combine them. And if you stretch AI towards singularity, or if you take robotics towards commodity, especially in the services zone, then it becomes far more critical. So I'll start with two examples. One of the remarkable examples which I see whenever I visit any of the emerging countries is definition of employment. So how do you define an employment? Do you define an employment of a person? And these are young, democracies.
Sure.
Right? Young, very young people. So you define an employment where one person repeatedly does one job, which nobody else is doing that because there's a need to put bread on the table. For example, in winters of Delhi, since you've mentioned Delhi, somebody manually cleaning toilets.
Yep.
Now, there is nothing against that particular job, so don't get me wrong.
Yep.
But that job can be easily replaced, and a better education can be provided. So the brain, this young brain, can be used, and these young muscles can be used to build something which has got creative element to it. So I argue this particular case. So I would like to take your view, first specifically bring robotics in a commodity zone. Does it make sense? Does it make sense purely from the politics of employment, and then we will touch the business part, and then later on we move to AI and singularity?
Sure. So I think I wouldn't like to term it politics of employment, because politics for me has a slightly kind of weird connotation. So for example, in the Turing Institute, we exactly deal with this kind of moral and ethical dilemma. So I would call it more the sort of moral and ethical implications and use of robotics as a solution. So you're absolutely right. One has to think about the complete implications. It's not just about somebody or some corporation or some industry taking robotics and solving a problem. It is about looking at the impact of that in a holistic sense. So, for example, in the context of data at the moment, there's already a lot of debate about how big corporations harvest the data that we produce through social networks and in turn add value to it and sell services back to us. So from a purely ethical perspective, that is not a very good use of your data, because I am providing some data which somebody is adding value and selling it back to me. So in theory, I should get back some royalty for providing that data. So I don't think robotics is very different. So I'm sure there will be a lot of scenarios where robotics is democratized in exactly the same way. So we will use the breadth and the depth of the data that's being collected to then run services that will eventually create profits. So from a moral and ethical perspective, we have to find a way of throwing the benefits back to the society. And this can be done in many ways. There's been a big debate in the European Parliament, which I was part of, the white paper on the ethical and moral use of robotics. And one of the debates on that was whether robotics or robots should be given an entity status, not just for the heck of it, because there's been some publicity stunts in Dubai with some humanoid robots being given citizenship. That's not what I'm talking about. What I'm really talking about is every time a robot is employed, should we think of it as an entity from a taxation point of view? Because every time a company employs a robot, should they pay a robot tax, which will go towards the social welfare and the social good of people who are displaced? You mentioned reskilling of people. It takes resources. So should we use those kind of income to provide for reskilling of jobs? So that's a dilemma that's people all over the world are facing it. And India is no exception.
So I'm going to stretch you on this. And I'm just going to focus on robots with no AI.
Yes.
Robots and two aspects of robots. One, they are machine.
Yes.
And second, not focusing on the fatigue management part of humans. Why do robots be considered any different than, let's say, a mobile phone in a commodity space? They're just machines, and they are levers. They help you to leverage technology, make your life easier. In an operational sense, each and every invention or each and every machine which has replaced a few people from a workplace or few people from a particular place. Why? What's so special about robots? Why they are considered special versus or considered, given the debate which is happening in the UK Parliament about all this?
So personally, I do not believe it should be different. You're absolutely right. Mobile phones create lots of opportunities and take away many jobs. Let's take a very concrete example. In Edinburgh, the sort of traditional black cab drivers were up in arms against Uber and the Olas of the world, but they have now adapted to the concept that it is democratized. There cannot be a single monopoly over a service. So I think this is exactly the same stage where robotics is going through. So that's no different. From my perspective, it isn't very different at all from a mobile phone or a computer, a personalized PC that was the specialty of certain labs 15, 20 years ago. And so I think physically what makes it different from people's perspective is because robots actually use the data and change the state of the world. So we call robots the arms and legs of the Internet of Things. So Internet of Things is all about connectivity and data, but it doesn't change the state of the world. Robots will act upon this world and make a tangible difference in terms of the state of the world. So that's a big difference. So from an external perspective, from people who see that, they think it is significantly different. But the only difference I see between a mobile phone and a device like this is robotics is called the arms and legs of the Internet of Things.
So this is just for young engineers or students who are sometimes in dilemma. They don't know how to address this whenever they are building a particular machine. And I'm just going to address for a few seconds robots as machine. You have mentioned, and this just occurred to me, you mentioned laptop or a computer. Laptop and a computer must have taken tons of jobs from accountants in terms of bookkeeping. Now, accountants were always reasonably paid or paid more than an average.
Sure.
There was no hue and cry about that, right? This came, people adapted it because maybe a laptop was not a movable laptop. It's actually very easy to make a laptop or movable laptop. So I'll tell you some of my experiences. A lot of engineers who were a part of my team, and when we were designing a robot which was supposed to ease services, and ease services across services sector, and the whole hypothesis was based on few things, which was a little bit controversial. Because India is known as a services industry and all that stuff, which was the hypothesis was based on a simple thought that any activity which is repeated and which is repeated with a lot of certainty again and again, whether it is a BPO industry, whether it is a hospital healthcare industry, whether these are airports, whether these are airlines, whether it is banking, should be replaced by simple robots and in a very, very cold way create a business case for that so that the shift size becomes lesser expensive. Fatigue management means replacement of just batteries and others go there. And that made absolute sense. But even between engineers, because I could see some of the faces saying that, hey, by the way, because somebody's relative was doing that particular job, you're going to take a job for it.
Sure.
Probably the last time I'm going to push the entire. Why? And robotics is an old school, right? It's not something, applications are coming now, much more visible form. Nobody questions robotics in the industries which you have mentioned, mining or aerospace or car manufacturing. Why in commodity space? So just to push it, why governments or why there is no debate of the quality of employment or quality of future jobs, rather than saying that, hey, by the way, this is not the right thing to do.
So I think the reason for that is disruption is always painful. So any new disruptor in a market, when they create a step change, there is always a pain point. And this pain point comes to various people in various ways. So if you try to introduce a new product to market, you have to, first of all, figure out, it may be the sums may add up, it may create an overall sort of profit for that particular company. So you have to make a case that kind of satisfies all of those ecosystems. Because, I think we discussed that on the flight, on the way here, because you said, if you put a robot there and then you had all the other peripheral services, which are still being handled by old traditional services, then you may have to pour in a lot of money to bridge that gap. So unless you start from a completely blank slate, let's say you're given a new town to design from scratch up, it's very hard to plug something in to an existing ecosystem without a lot of pain. So I think it is the governments, it's the companies, it's the society which takes that leap of faith, which will benefit in the long run at the expense of pain, short-term pain. So, and I think that is really the case. And this is not new to robotics. So we are now in the UK, in the US as well. So this is exactly the debate facing autonomous driving cars. So I'm involved again with some lawmaking number 10 debates at the House of Lords. We had to give evidence. And one of the biggest questions that were asked of us was, you will not, with these autonomous driving technologies, even if you have the perfect technology, in terms of sensing, in terms of autonomous driving, in terms of replacing people, you are never going to, on a particular day, switch off all the other people with their cars, with their manual driving cars and gears, and say, from now on, it's going to be only autonomous driving cars. So you have to have this transition phase between autonomous driving cars to working in conjunction with the current existing legacy systems. You also, so my belief, and this is part of my talk that I gave in Edinburgh, is that we will never achieve one or the other extreme. So that's the concept of shared autonomy, where a significant part of the system will be moving more towards, it's just the slider that moves. So we are now moving more towards significant more autonomy, but still human in the loop kind of setting. So we need to have a scenario where as we move the slider, the pain points of the ecosystem around it has to be addressed. And now, I'm not the person who can give the answers to who needs to address that. It may be governments. So I know that Singapore, for example, is a very good example of a government stepping in and pouring some resources to bridge this pain for the people who are being disrupted. It may be in the Silicon Valley. It's really more the kind of West kind of way of, whoever survives, whoever doesn't survive. And I don't know the system here in India, but it's somewhere in between, I think. So somebody has to address that point, that pain point for that transition. That is really the issue, I think.
So from here, let's get into the fun part of it, which is engineering of robots.
Sure.
Now, I'm not going to talk about expensive robots because I myself don't have fun for it.
Sure.
I have an expertise to it. We talk about robots which are cheap but robust, robots which have got a wheelbase, which are easier to construct and all that stuff. For the audience, just take us through what are the simplest things to think about when you design a robust, cheap robot with a steady motion and activities which make sense.
Yeah. So really, I think the robots that you can build range from a few hundred rupees to a few $1 million. So there's a huge range. And that in terms of the cost and in terms of the fidelity of the machines, as well as the kind of machines that we built. So, for example, in our lab in Edinburgh, so we work with all sorts of robots. We work with fixed-base robots, and these are examples where it's clamped onto a base, doesn't move, and then you've got multi-degrees of freedom arms, probably seen it in some of my videos, which they collaborate with. Then the next step is now moving from that fixed base to wheel-based things where the base moves. It's still a relatively simpler control problem because when you kind of leave it, it is stable. It's not a highly unstable dynamical system. Then you have scenarios where you go from wheels to quadrupeds with 4 legs or 6 legs. And these are machines that are designed to navigate complex terrain. And then the other end of the spectrum is bipeds or humanoids. And those tend to be more expensive, more specialized, more high-end, high-value stuff. So there's a whole range of things. So my sort of thought process, research is one thing. So I have a huge passion in doing cutting edge research, which pushes the envelope in terms of control, in terms of data-driven ways of adapting robotic platforms, sensing. But when it comes to solving real problems, so I think one should not start by looking at a robot and trying to figure out what can I apply it to. It's got to be the other way around. You've got to say, there exists an issue, there exists a problem, there exists either an inefficiency or a problem or something, and that I am trying to find a solution to that using robotics as one of the nails in your arsenal. So that should be the approach. So often people do it the other way around, and that's where people fall in trouble. So in a way, you have to think about what is the value proposition in terms of what you're trying to solve. So I think it very much depends on the industry. So I have, for example, been interacting. So we have a project with IIT Kanpur, and that's part of my visit. Yeah, so we have a project on intelligent warehousing in India, and it's very different from the Amazon kind of warehousing situation that where everything is controlled. Here, it's a slightly, you've got to look at various parameters, like you've got to deal with the heat and the dust and the slightly more unreliable sort of components. So we need to have more redundancy built into the system. Labor is relatively cheaper. So I think redundant systems, which may involve more repairs, are okay here. And so that's the kind of local context that we need to build into. So we also work with the AI Valkyrie Institute in Mumbai. And so they are looking at, instead of looking at technologies, they're looking at the verticals in terms of what are the problems that we need to solve. So for example, they're working with farmers for looking at crop, fertility prediction based on various things like atmospheric pollution, rainfall, various other parameters, doing what we call personalized solutions to agriculture. There are other scenarios where people have been looking at sort of frugal innovation in the context of basic sanitary requirements. So it could be toilets, could be low-cost housing. So how can we use robots as a way of 3D printing cheap technologies for building houses? One day you can take a cement and a 3D printer on the back of a truck, and in, say, 2 days, you can print 3D printed low-cost housing to replace some of the settlements that are not so hygienic. So those are the kind of sort of solutions which address the need and the envelope, but also provides technology to deal with that. And one other thing I want to mention is the area of healthcare. So India has, again, a huge diverse population, which have got a significant variety of access to resources, whether be it internet, whether be it mobile phones. So getting healthcare to the nooks and corners of India is a big challenge for the government. And there has been some brilliant use of, I would call that robotics as well, but of technology that can be added on or fitted onto your mobile phone, and you can use it as a lab on chip to kind of use it to take blood samples, oxygenation samples, and detect early onset of problems like diabetes, or just use a camera, look into your eye. Microsoft in India runs that program in Bangalore. Use it to identify the propensity of getting diabetes, which is a big problem in India. So cancer is another issue. So are there ways of using immersive technologies like robots with a screen and some basic diagnostics to then access expertise sitting somewhere centrally? So there may be an expert doctor who will not have either the resources nor the will to travel to the remote places, but he can deliver his expertise through some remote presence. And this could be in waiting rooms in airports. It could be in waiting rooms in schools. Wherever there is dead time, wherever there's thing, you can have these kind of delivery of services from a centralized place without the need for physical presence.
No, I totally agree. In fact, one of my passion in terms of building robots for India is to combine multiple technologies, and then you actually, instead of taking one robot at a time, if you actually consider family of robots, so you do different versions where you use drone in a non-sexy way and you use robot and all that stuff, then you can actually do this last mile delivery problem and you can sort of whether to take water wherever.
Yes.
Go to remote areas of northern part of India, without mentioning a particular state. A lot of hard work is done by them in terms of taking water, and they do not like to meet because of the certain practices with another way.
Yes,
robot is genderless, so and it can deliver.
Absolutely,
you can actually solve a lot of cycle time issues in terms of where the doctor is.
Yes.
When the doctor will arrive, how the payment happens in cities in terms of healthcare, and you can utilize that those resources which you save into something which are much more human, where much more human contact is there.
Absolutely.
So there are multiple use cases. Now, since you mentioned that, and since you mentioned about your passion about research, we'll talk about two things: family of robots, and we'll get into this issue which most people talk about, but most people don't have any idea of what they're talking about. Is family of robots. One is very simple, which I mentioned, which I call as industrialization. That means machines, different kinds of machines are working together on a particular data set, solving a particular problem. Whether you call them robots or whether you call them machines which can walk, fly, do things, is a separate thing. There are several examples of that. A lot of people talk about AI, and the moment you mix AI with robots, they say, hey, robots are going to create their own families, they are going to take over the world, or they're much lesser data will become intelligent, and that intelligence will make robots far more superior, and their mistakes cannot be governed per se. So what is, as a person who's doing research and who has this kind of a view of future, what do you see? How much truth is there in these kind of talks, and what actually research is happening in this area?
Absolutely. I think what you're referring to is this whole concept of singularity, and people sort of all the way from, not just anybody, but people like Elon Musk and Stephen Hawking and people, very reputed people, talking about the dangers of AI and robotics if you don't be careful. And so I think there is, without doing any kind of fear mongering, I think there is some truth to the core nature of their worries but that is not in terms of the robots are going to take over and, be the Terminator kind of scenario, but it's a completely different thing. So one.
Do you believe in that Terminator kind of scenario?
I don't. I personally don't. I mean, I keep joking to my guys in the lab that, if a robot chases you, just walk up 3 stairs, a flight of stairs or steps, and it won't be, because with current technologies, climbing steps for a biped robot is pretty much impossible. So in a way, I think there is a populistic, journalistic view of things. And then as you pointed out, people who work on the research understand the integrity of it. So the dangers come not from the fact that the robots are going to have a mind of their own and take over, but it comes from the complexity that we're building into the system. So, for example, we do a lot of research. You mentioned swarms of robots and IoT of drones and robots talking to each other, solving a problem. So we are actually working on particular problems at the moment. So we have a large funded project called the Orca Hub in Edinburgh. I think I briefly mentioned that. It's about use of drones, underwater vehicles, and land and topside vehicles for maintenance of oil and gas rigs. So the point is, we want to take people out of harm's way and only have, at the moment, there are about 40, 50 people on the rig. Reduce that to 4 or 5, and everybody else works on an office onshore and monitors everything, and only intervention which cannot happen in the kind of setting in which we need a human in the loop. That's where they do this kind of supervisory kind of role. So that's already happening. So in building those systems, what we have found is that scientific research that we do, the added value that we bring to the story is when we use the data that we collect from the robots and then use it to train systems that learns and adapts itself. That's the key word, learning and adapting. So what's different from the traditional way of doing robotics is that earlier, the robots that you talked about in terms of running factories and building cars, they are pre-programmed to do a particular thing repeated again and again. So your input-output relationship is very, very clear. But when we have learning systems, adaptive systems, it does improve the quality of the performance of these robotic systems. But at the same time, what it does is it adds uncertainty in terms of the behavior of the robots. Because when it adapts, we use this notion of value functions. So we have to define, using some cost functions, what is good behavior and bad behavior from a robotics perspective. It uses this value function to change and modify behavior. So for example, a simple example, if a robot comes and picks up a load and it tries to move it to a particular place, if the load is different from what it's expected, then obviously it will not get to where it wants to be, but it will learn and adapt all the time so that it changes the forces it applies next time it does. So what's happening underneath that is that in response to a particular input, the behavior of the system is constantly adapting and changing to an extent that people can't predict the behavior of those systems. And when you have multiple interconnected systems, it becomes even more complex. So the danger is not that the robots are going to take over and do things. The danger is in the interpretability of the actions of the robotic platforms. When you as a programmer program something and the same thing happens again and again, if something goes wrong, it's easy for you to diagnose and fix. But the moment you've got swarms of systems or learning systems or adaptive systems, diagnosing the causal reasoning of failure becomes much harder. And that's when you kind of get into trouble. So my worry is that we will build complex enough systems with the right intentions of the robots adapting and improving themselves. But when something goes wrong, we will be unable to rectify, decipher, understand the causal reasoning. Is it the sensor that failed? Is it the actuator that failed? Is it the logic that failed? Is it the adaptive system that has come up with some loophole that we hadn't thought about, that it is exploiting to address a particular cost function? So that's the real danger. And that's why we are now focusing with the DARPA, with the US government, with the Turing Institute, we are focusing on a whole swath of programs focusing on verifiability and traceability of AI and robotic systems. So the government has sort of mandated that any robotic systems that gets deployed or in public spaces, in hospitals, in airports, in other public spaces, which are not controlled, where humans can come in, they need to have some sort of certification. And this is not the traditional ISO certification of circuits and diagrams and fuses. It's about verifiability of actions. In other words, if something goes wrong, can you trace back the causal reasoning of why that happens? And in learning systems, that is hard. So there's new science that needs to be developed to address that. And for me, that is the bigger worry than robots Terminator scenario.
This is just for students and
Sure.
engineers. In fact, mostly students who are not pertaining only to robotics, but who are writing code, and who are writing tons of code, like AI, ML, mostly in DL area. People confuse between cognitive ability of a machine or cognitive ability of a code versus uncertainty, which you have mentioned. What's the difference, and where is the thin line, and how these two things are extremely different than each other?
So cognition is a very gray area. So I always try to tread very carefully, because you can take you're probably aware of the thing called the game of life, right? Yes. So it's a very simple sort of local rule-based system, and you kind of create, say, 50 agents with that game of life thing, and you put it on a board, and it will look as if, when you let it evolve, it'll look as if it has some character. So people who interpret it, an artist or a person who's not a coder, who sees that and may think, oh, that thing has got emotions, that thing has got cognition, that thing reacts in a particular way to certain inputs. So that has got certain things, whereas it may be a result of just very simple basic rules. So, and of course, cognition in humans are a much more complex thing. So although I've done a bit of neuroscience myself during my PhD and sort of postdoc times, I think we are still far away from understanding the inner workings, the neural basis or the neural cognition, basis of cognition. So I think it's kind of foolhardy to contemplate on the workings of that. I think in terms of the software engineering and the kind of things where people are trying to address evolution of programs, the stochasticity that we mentioned, we are seeing scenarios where people have forgotten the basic notion of software engineering, how you kind of debug things. It's not their fault. It's because the complexity of the systems are evolving. And for me, I learned a huge lesson working with NASA on this. So flight systems, you fly aircrafts, you're aware of aeronautical systems and safety critical systems. So NASA, every piece of code that flies is checked by so many people. It sits on a unit testing for 6 months. And any change people have to do or any uploads done, you have to run unit tests for 6 months in all sorts of scenarios. And the problem is that the speed at which things are going now in terms of evolving, that kind of critical testing is not being, there is no time or money to do that for all these systems. And case in point is autonomous driving cars. You saw the scenarios with Tesla, you saw scenarios with Uber, where people said, there has been these accidents, so let's try and find out why these accidents happen, and there's not enough testing of certain scenarios. So the dilemma is, do we wait till we get all that 100% correct before we deploy things, or are we willing as a government, as a society, to experiment a little bit, deploy it, learn from mistakes? And to be honest, if you look at the statistics, the mistakes that Uber or a Tesla or a thing makes for the number of miles it is run is much less than a human-driven car. So you can rationalize that this is certainly more safer than a human doing it. But that's not the way people think. A software system, a robot makes a mistake, there's a big hue and cry. So the debate is still up in the air. Should we wait for everything to happen? So the stochasticity business that we just talked about comes from the sheer complexity of these things that arise out of these machines. Yeah.
We'll do this discussion because I'm tempted to do this discussion, but this is going to take hours and hours of time. But the funny thing is, what we call as bug in a program is mostly interpreted the moment that bug is done by a machine, and people call as robot as intention of a machine. Mm-hmm. Yeah. And that causes a lot of complexity. In actual sense, in a very, very core engineering sense, it is just a bug. So when you were talking and I was listening, I just thought of this example. Suppose if a robot is managing traffic, and if a traffic policeman does a mistake, then they say it's a mistake, and you go through regular procedures and all this stuff. And if that mistake happens in a scenario where he stops a car and then his hand basically goes
some battery malfunction or whatever,
and robot moves forward, basically the intention of the robot was to hit the car.
Yeah.
Essentially, it was just about, maybe somewhere the obstacle recognition software has gone. But that's the funny side of things. Hopefully, the education part or the awareness part of evangelization of robotics and their use cases will cure this problem, which I see that because it has become quite a sensational storytelling, saying that, hey, what harm robots can. While engineers have never made a claim that robots can be equivalent to a human, or robots are nothing more than just machines who can do several things at the same time. In a country like India, what we have to do, so we create brilliant robotic engineers. Brilliant research happens in robotics. There's an overall question in India, both from an educational system perspective and from the research. First of all, it's not happening, and correct me if it's happening. I don't track, but I meet a lot of educationists, and they say that there are a lot of smart engineers, but they go back, and then later on, some of them come over here. But fundamentally, they go because of resources or whatever. So I don't know, but I have in my own team several engineers who are remarkable engineers. So what do you tell them in terms of future of robotics in countries like India, future of research in robotics in countries like India, education system and how it has to change, if it has to change in a specific area of robotics, since you are in touch with the academia?
This is a tough question because I've been out of the country for a while. So, but in my limited interaction with institutions like IITs and the Indian government and Niti Aayog and the Valkyrie Institute, I've found that you're absolutely right. There's a huge talent pool. Also, I think the impact that a single successful program can generate in a country like India is much more massive than in a Western country because of the sheer population. So I think there's a huge potential. So what I find slightly disconcerting in my interactions with students here is the lack of depth in which people train on certain areas. So many of them are very good generalists in a broad range of things. But my feeling, and I tell that to my PhD students as well, I think you need to have initially as a training. I think we've got a great undergraduate system, mostly very good, well-trained people. So we get a pretty decent base, say, skill set and tools. But then it's the next step to tackling or pushing the envelope on a particular problem is about going in depth in one area. And I feel that at least in the Indian system, I mean, again, this I'm looking at it from as an outsider perspective. And so this is not a well-informed comment, I would say. So don't quote me on that.
It's not only me.
Yeah.
There are a lot of my peers, in fact, there are a lot of industries who have made a comment on this, that we have a decent undergraduate system, but they are not employable.
Yeah.
So once they need an employment, and in a very, very generic way, the employment, they have to spend some money to employ them.
Yeah.
So that again, but from a robotics perspective, so I share my view, just to simplify things. I actually, when I started my first project in India to build a robot, there was very less support. In fact, support overall. Why do you want to do it? Overall, from everyone. Why do you want to do it? There's a lot of labor, which is cheap labor. Why do you want to? So, but when you actually do math and when you get into depth of that particular math, that's a business math, it actually makes a lot of sense.
Sure.
When you actually get into problem solving and details of problem solving, robotics in India actually makes a lot of sense, because it actually helps you to leapfrog some of the constraints which you already have in infrastructure over there. Right? They are not taught these things are not taught in schools. Right? One is that. So I don't know why they are not being taught, or whether people who teach, they don't have education material ready, maybe they don't think like that, or maybe students are not willing to do that. I don't know that answer. The second thing which I have seen is exactly the details part of it. So which part, how to manufacture that particular part, which part is suitable over here, how can you go in depth design, should you use open source in coding, are you good in coding, can you code, So you go through all these columns and it's very difficult to find them. What I did was apprentice style. So you sit with them and you say that, hey, I'm an engineer, so all of us let us sit and you and
work on a particular problem in depth.
And you do that. And you do it hands-on. At least my teachers, I have not seen them sitting next to me coding. I have not seen them saying that, hey, by the way, this is a problem which exists in a world in which Indians breathe. And I'm taking that particular thing in academia and I'm trying to solve it. I have not seen that. So I'm with you. Now, I don't have data in front of me, which, other government organization, whether they are Niti Aayog or something. But I meet with these guys and they understand there is a problem. Just whatever interaction you have, because I don't interact much with academia anymore in India. Whatever interaction which you have, do you see things changing here, or a quality of research going, or even there is an intent to do research?
Definitely intent. I think there's definitely intent. And the levels of implementation vary. And so you mentioned Niti Aayog. So one of the things I was about a year ago, I was in conversation with the principal scientific advisor to the government of India. So Vijayakumar, he's a good close friend of mine through his time at NCBS in Bangalore. So we had a kind of projects together. And he now heads the government's initiative here. And he has very strong views on how to push things. And I think Niti Aayog has come up with some sort of rubrics. I think it's a very well-written document on robotics and AI for India. Arnab Kumar, who again is one of the key authors of that document, came and visited me in Edinburgh just a couple of months ago. So they have a very good blueprint of how to do this using these concepts called cores and ICTIs. So cores are Center for Excellence, which is led by things like IITs. So we've been in dialogue with IIT Madras and Mumbai on some of these things. But it enforces that the government will only put in money if there is a buy-in from the industry. So that's a good way of getting the real world problems matched with the academic excellence. So in theory, that's great. There's another set of vehicle called ICTI, which is industry driven. So Tata, for example, Tata Robotics in Pune, I visited them. So they have their own little niche in terms of, you probably know well, in terms of the arms that they manufacture, which is neither too expensive nor too cheap, but it's very good for their sort of manufacturing purposes. So they are potentially leading one of those ICTIs, but then bringing necessary expertise from academia to kind of contribute. So these are, I think, very clear, roadmaps and blueprints for delivering this. But on the ground, I think there is still a way to go in terms of taking that idea and running with it because of the pure incentivization. That's my worry. So sometimes the incentivization is not right. You need to incentivize people with the right, financial, economic, as well as some sort of leadership qualities that will deliver that vision. So vision is there. But I think it's about delivering that. So that's my sort of feeling. And lastly, I would say that I have been quite impressed with the new kinds of institutions that have come up. So Tata, TIFR used to be the kind of flagship research organization, high quality people with the freedom of thought and freedom to blue sky thinking. But there have been similar things that came out of so NCBS I've worked with in Bangalore. There's a Maths Institute. And there are some institutions, so the one institute is a privately funded one. There are these centers of excellences which have the right incentivization in terms of getting the excellent people together and giving them the right incentives to not just go through their, lives as publishing some papers and then throwing it over the wall. I mean, I was just recently reading somebody saying, academicians, they write a paper and throw it over the wall, hope that someone picks it up and does it. But they are now thinking impact. So what does the work that I do, how does it create impact all the way? Not necessarily doing the last mile of engineering, then companies can pick it up, but at least show the way how to get there. So I'm impressed with the new wave of such research organizations. I think that ethos is filtering down to the top institutions. So I now go to IITs and they say, it's not just sheer number of grants that you get from, but it's about the H indexes and the citations, and the impact factor, how many spin-outs that come out of that. I think those are the right metrics. Now, you cannot change something overnight, but I think the incentivization has to be right.
On that positive note, any message which you have for engineers who are on the verge, computer science engineers who can, or electrical engineers who are on the verge of doing research versus becoming specialist robotics engineer or AI developers? Anything for them?
Okay, the one thing I have to say is that I think there is a role for all kinds of people in today's society. Whether they are coders, whether they are designers, whether they are people who conceptualize solutions for a whole global system. So it's about finding a niche, not following the crowd in some sense. So you're a good example of that. I think you're a person, the reason why I found you really interesting when I was talking to you for a brief amount of time is because, I think you're somebody who broke the norms in terms of what is a traditional career and sort of really follow your passion. So I think that is important. I think that is hugely important because in terms of driving something, it's not enough if you just do something that's 9 to 5. You need to have the passion for doing it. And if you are not suited for a particular kind of thing, then change. And it's no point sort of doing something that you don't care about. I enjoy going to work in my case because I'm excited about the new kind of things that you do. Of course, you need the support of a huge network of people. So in my current role, I do my amount of actual research I do is actually quite minuscule, but I direct a lot of research with the right team around, with my PhD students, my postdocs. They are the ones who keep me young in my sort of thought process. And I think that's what you need. And so for me, it's about being passionate about what you do. From an engineer's perspective, it's about finding the passion. And for the Indian government, I would say it's about helping reduce the red tape on all of these things, giving people the freedom to express themselves and reducing red tape. That will really propel the economy and the research here.
Passion and freedom.
Absolutely.
Thank you, Professor Sethu. It's an honor and it's a privilege to do this. I'm sure every engineer and every person who wants to become an engineer or wants to become anything will benefit from that. Thank you very much.
It's my pleasure. Yeah, thank you.
Thank you.
Yeah.